We have started a new topic that is known as your multi-threading in Java. So through this topic, we came to know about that, okay, that in Java, Java supports multi-threading. Means if you want to perform some task, okay, if you want to perform some concurrent execution of our program, so yes, we can do it because Java supports this thing. Because in Java, we have a library, okay, that is inside our java.lang package. So inside java.lang package, there is a class named as your thread class. So using that class, there are many methods that are there. So today we are going to discuss about few methods, okay? And using those methods, we are able to basically perform our multiple threading task. Means we will create multiple threads, and using by creating those threads, what we are achieving, we are basically performing concurrent execution of our program. So earlier in our labs, like in our 2 days, like whatever the labs you are getting in, even in this week also. So basically the program which you are basically using are known as our sequential programs. Okay. So you are not executing. So it is executing in a sequential manner. But during the disadvantage of our sequential programming is that suppose if one of our method or one of our statement is asking for suppose input output operation, and it is just waiting for this input output operation, then at that time our CPU is not performing any task. So just because of this thing means our CPU is idle, it is not performing any operation. So we want to utilize this time. So in order to utilize this task, what we generally do, we generally create threads, right? So suppose if we create T1, T2 thread, so if T1 is waiting for some input output operation, so at the same time, if a T2 finds out, okay, CPU is free, then T2, our thread T2 will start executing, okay? So that you will find out that after performing this multi-threading, we are able to perform concurrent programming, and we are able to utilize our maximum, our CPU utilization, or we will get our maximum throughput, right? But as I told you, like in next lecture, when we are going to discuss about synchronization, then you will find out that concurrent programming are not that much simple. They are somehow complex, because it's not like that we will create multiple threads randomly. No, we cannot create. We should have an idea about, okay, how many statements are there, whether these statements are relatable or not. If statements or if methods are independent to each other, then only it's better to go forward your multi-threading concept, right? Now, so I have given you all these things, all these examples we have discussed so far. So in our last class, we have discussed about that if we want to create threading, okay, if we want to use the functionality of threads in our Java programming language, so there are two ways. Okay, first one is by extending our thread class, this which we have discussed in our last lecture, and there is a second way that is known as with the help of our runnable interface, right? So in our last lecture, we have discussed about that how can we create a thread by using thread class. So as you can see that in our Java programming language, we have a package, the java.lang package, right? Java.lang package. So inside this package, you will find out that there are many classes that are there, which we are using nowadays, like your exception class. So we are not importing any separate, you can say that package for if we want our exception class, right? So all these classes are there inside our import java.lang package. Similarly, there is a class that is known as our thread class. And this class is also listed inside our java.lang package. And java.lang package, we can generally call it as our default package, right? So we inbuilt, we got it. Whenever we are writing or whenever we are compiling our code, our compiler will provide us this particular package that is known as your java.lang package. So whenever we are basically creating any threads, remember, whenever we want to create any thread class or whenever we want to perform the concept of your multi-threading, remember this point that we have to inherit or we have to create a class which will inherit your thread class. right? So in the last lecture, we have seen like many examples related to that. And the second point, which is very important, that using thread, it will always execute. If you want to perform the functionality of thread, so you have to give some sort of task to that particular thread class, right? So every job you have to write inside your run method. Remember, this run method is already there where inside my thread class. But inside this my thread class, this method, which is public void run method, this is a concrete method, but it doesn't contain any statement. Yeah, right? So whenever we want to execute this particular scenario, whenever we want to perform any task, so it is mandatory for us to write these statements inside our public void run method. Now, whenever we are going to create a child of this method, so what I have to do, I have to basically create the child of this particular object of this particular what, this method, and then I have to use a method that is known as your start method. Whenever I am going to write start methods, which we have discussed in our last lecture, whenever we are going to write t dot, suppose we have created an object of this reference variable t of this particular class, so it will directly execute t dot start over there, right? So this is all about what we have discussed in our last lecture, right? Now in this, what we have gone through in our last lecture is that whenever we are executing our code, we are getting different outputs. So if someone will ask you that, okay, can you tell me about that, if we are having two threads, which are T1 and T2 thread, and suppose T1 is executing hello world and T2 is executing hi world. So can you tell me like what will be the order of execution? Then always remember, we cannot comment on that what will be the order of execution, because this entire execution task will be handled by our thread scheduler. Okay, so there is a thread scheduler which is present or which is available inside our JVM, and it varies from JVM to JVM, right? So whenever we have different JVMs that are there based on our different operating system, so we might have different functionalities of JVM too. Okay, so inside this JVM, we might have different thread scheduler. So some of the thread scheduler might performing first come first serve, means the thread which is coming first, we are going to execute that particular thread. Some of them, they generally use round robin fashion, means they will give us some sort of time quantum, like okay, for first 2 seconds we will execute our T1 thread, for next 2 seconds we will execute our T2 thread, something like that. Okay, so we cannot comment on that what kind of basically algorithm they are using right now. So always remember that this thread scheduler is a part of our JVM. So in our last lecture we have discussed everything. Okay, I have already shown you like various like cases how we are basically going to execute our code, right? So t.start, always remember, using this start method, we are able to invoke our thread class. Okay, then only we are able to basically perform the we will execute what our concurrent task only in that particular case. If we are not going to write t.start method, if we are not using this start method, then we won't be able to perform what multi-threading themselves, right? Now, so it is responsible to schedule your threads. If multiple threads are waiting to get a chance, in which order threads are executed is done by our thread scheduler. Okay? So all these things we have discussed in our last lecture. Now in this lecture, what we are going to do, we are going to first we are going to discuss about what is the difference between t.start and t.run, and then in next we are going to discuss about the second case. Okay, right now we are talking about our first case, that how we are going to basically execute our how we our this multi-threading concept. Now, first of all, I just want to give you one example, like what is the difference between t.start and t.run. What I have told you, that there is a class that is known as our thread class. So inside this thread class, there are many methods and there are many constructors. Remember that this is an inbuilt class that is already there in our Java programming language, which is having several methods as well as several constructor of this our thread class, right? Now, out of which there are two methods. First method is our start method, and second method is our run method. So till now, what we came to know about is that whenever we want to create any of your thread, whenever we want to perform some concurrent task, so we have to call this particular method, right? And whatever the task we have to perform, whatever the job we have to perform, so we have to override this method. Remember, we have to override this method, and this method inside this method we have to write our whatever this code you want to run. So in our first example, what we are doing is we have created a class main inside our public static void main. If somebody is going to ask you like in this program, how many threads are there? So you will say that there are two threads. Remember this point. There are two threads. First thread, always remember whenever we are executing our code, our JVM by default, our JVM will provide us a single thread. So right now, your labs, whatever the code you are writing, you are basically working in single thread. Means you are using only single thread, right? But now here in this case, after writing this statement, not after writing this statement. Right now, after executing this statement, basically I'm just creating an object. So that is same. That is okay. No issue at all. But after executing this statement, now I will have two threads, right? So initially you can assume it like that. Initially we have main class, means we have only single thread. After executing this statement, now I have two thread. First two thread is my th1 thread, and second thread is what my main thread. Now these two threads will do what? Now these two threads will execute your parallelly, right? Now how they will execute? Like all these things are going to be managed by our thread scheduler. Okay, like that. Now, after that, what will happen? Whatever the statement, remember, whatever the statement that are there inside my run method, all these statements will get executed. Okay, all this only if suppose we have one more method now, like I have given you in our last lecture, I have given you. Suppose we have one more method, void display. So remember, it won't execute this method. It will execute only our this method, that is our run method. Remember this point. So that is why what output we will get like any output. It's up to, it depends upon our scheduler. I have shown you like we are getting different output. Like first time we are getting child thread, 10 times child thread, 10 times parent threads. It might be possible we might get first parent thread, then child thread, something like that, and some alternation we might get. Okay, alternative output we might get. Okay, so this is the right way of performing what our multi-threading. But some of you might say that, sir, what if we directly, because here we are performing this your multi-threading concept, so it's better to directly call this particular method. So in my second case, what I am doing, I am not calling this th1.start. See, remember what I am doing right here. I am directly calling this th1.run method. Now, if I'm going to execute this code, now remember, I won't get any error, even compilation error as well as your runtime error. I will not get any error. But here in this case, actually, if somebody will ask me, sir, can you tell me about how many threads are there in this particular program? So remember, here we have only one thread, that is our main method. Okay, this main thread we have. Here we are not creating, okay, we are not creating any thread. Now the question that comes into your mind is, sir, but we are calling this method. So like in our nowadays what we are doing in our labs, we are directly calling this method. Na? So in the same way, basically we are calling this particular method. So basically we are performing sequential programming right now. So in this particular case, the output will always remain same, that first I will get child thread 10 times, then child 10 times parent thread. I won't be able to get, means I will not get different output. Why? Because here I am having only one thread, and the one thread will always follow sequential programming. Remember this point. So here I am just calling this method in a simple mode, but here I am calling this thread method. And remember, in this start method, now that is there inside my this thread class, it contains like tens and thousands of lines of code. Okay, so through using that, we are able to achieve this this particular what functionality, right? So remember this particular point. So here, as I told you that here the number of thread is 1, number of thread is 2, hence a new thread is not created and is executed, normal overloading possible, and here it is mandatory to override run method. Okay, so otherwise it will not get executed, right? So I have told you about the entire scenario. Now what we are going to do, we are going to learn about thread life cycle, because we should know that how we are going to create a thread, right? So whenever we are writing now, like in this program, whenever we are writing, so we are just going to discuss about this program, because here we are performing what multi-threading concept, right? So whenever we are executing this statement now, so in this statement we have created as we have entered in a state that is known as your new state, right? It means we have created an object of your your some thread class, which is overriding or which is basically inheriting your thread class right now. After this, whenever we are basically going to execute t.start now, this statement, then my thread will move from new state to ready state. Ready state means now my thread will say, now th will say that okay, now we have created a thread, now I am ready to execute. Okay, like I have given you this example now. This now th1 will say that now I am ready to execute. Similarly, main is saying that okay, I am also ready to execute. Now after that, this our thread scheduler will tell us okay whether we should give him or give that particular thread some processor or not. So if they are basically providing us some sort of processor, then we will go into our running state, means we are now executing that particular thread statements that are inside our run state, right? So once this entire run method completes now, it means now that my entire thread, we have executed our entire thread. So if we are able to execute our entire this run statement, then it means that we are able to complete our run statement. So automatically it will delete this particular thread. Okay, so it will automatically delete this particular thread. So this is basically nothing but the thread life cycle. Okay, so here always remember new state, ready state, running state, and your dead state. Note, after starting a thread, if we again start a thread, we will get a runtime illegal statement thread. What I mean to say is that just after th1.start now, again if I am going to write after this statement, if I am going to write th1.start, again if I am going to write now, then what will happen? I will get a compile time error, right? Remember this point. So we cannot start a single thread again and again, right? This is a very important point. Now this is the basic task of our scheduler. So here you can see that between these two states, how we are able to go from this state to this state, basically we have a scheduler, right? So here we have a scheduler which will take the decision, and based on this his or her decision, you can call it as that we are able to switch from ready state to your running state. So this is the basic idea of a thread scheduler. So it will tell us whether you want to go from runnable state to running state or running state to runnable state. And there might be different approaches which we are going to learn in our today's lecture, through which we are able to go to blocked state also whenever we are not getting some resources. Okay, so what it will do, our thread scheduler will say that, okay, I am putting you inside this your blocked state, right? So if somebody will ask us that what is the exact thread life cycle, then this is our exact thread life cycle. So when first we will go into your running new state, then we will go to your runnable state, and that will be your terminated state, right? So inside our runnable state, you can see here that we are having multiple other states too, like waiting state, blocked state. So in today's lecture, we are going to discuss about these methods. Okay, so there are many methods. We are not going to discuss each and every method, but we are going to discuss about most common methods. And using those methods, we will find out that, okay, using those methods, we are able to perform, and we can move our that particular thread into your waiting state, like in our sleep method. Okay, so sleep means like it will put our thread into our which state into our sleep state, means at from how much time we want to put this particular thread t1 into your sleep state. So it will keeps on waiting and waiting and waiting like that. Okay, so all these things are going to be managed by our scheduler, right? But still we are also having some other methods too, through which a programmer can also do these such kind of operation, whether we want to put inside our waiting statement or your blocked statement, something like that, right? Now this is just an example. So in this example, what we are seeing over here is why we are getting an error. First question that comes into your mind is, sir, why we are getting an error? So the reason why we are getting an error, see, we are not getting a compilation error. If you will see over there, we are not now, because after going through covering your exception handling concept, now you already have an idea about that. What is the difference between your compilation error and your runtime error? Okay, what do you mean by exceptions? So here you are getting a runtime error. Why? Because you are also getting some output too. So here, why we are getting a runtime exception? Because you can see over there that for the same thread, that is my th1 thread, which is basically pointing out the same object, we are calling this particular particular object multiple times. Okay, so that is why we got thread parent at child 10, and after some time, so you might get different output too. I'm not saying that every time you will get only 3 statement it will execute. It might execute 4 statement, 5 statement. So it depends upon, again, upon the scheduler. But the main thing which we have to notice from this particular example is that we cannot invoke a thread multiple times. Remember, we cannot invoke we can create second thread, okay, th2, like this. We can create multiple thread, like example thread. I'm just writing example thread new is equals to new example thread, right? So I can create this thing and I can invoke th2. It is possible. I can create 3, 4, 5 thread. It's up to us, like how many threads we want to create. But remember, for a single thread, which is basically using a same reference variable for a same object of that particular thread, we won't be able to basically pointing out like multiple times. Okay, so in this particular case, what will happen? We will get a runtime error. Now we have discussed about how to create a thread using with the help of our class. Okay, so using class, we are basically what we are doing. We are able to perform the functionality of our multi-threading. Now I have told you like there is a one more way through which basically we can perform what our multi-threading concept, and that is using your runnable interface. So remember that in our java.lang for this package, we also have a runnable interface. Remember that we also have a runnable interface, and remember that this class, which is already inbuilt class, that is our thread class. It is basically implementing this our runnable interface. It means that if we'll see the hierarchy of our this entire thread classes, as well as among with this particular interface, so you will find out that first they have created this runnable interface, and then after that they have created this thread class. And remember that this is very important, that inside this interface now, that you know that how to create an interface. So in interface, what we have, we have only your abstract methods. Okay. So if we are not basically, basically in runnable interface, we don't have default method, something like that. Remember this point. So we have only what your abstract method, and what abstract method we have? We have public void main, public void, sorry, run method. Okay. So basically we are getting this run method. Okay. So whatever the example, whatever the basically program we are executing now, see this run method. Actually, we are getting this run method from where? From our runnable interface. But then this runnable interface, who is implementing? Our thread class. So all these things are inbuilt. Okay. But after that, whenever we are basically, so this is the first approach we have basically used so far. So whenever we are inheriting this thing, so automatically we will get run method too now. So that is why we are not at all concerned about our runnable interface. So this is the first way basically how we are creating our your thread class, or we are basically performing the concept of your multi-threading. While in the second case, if you will check it out, like in our second case, we are using your runnable interface. And using our runnable interface, we are directly creating a class. And you already know that how can we create a class? We have to write a class, my runnable. And then I have to use what? Extends on implements. I have to use implements. Right? Implements, and I have to write the runnable name of this runnable interface. And then after that, if I'm going to execute this program now, then I will get an error. Why? Because this interface contains one abstract method. Either you make this class as what your abstract class, otherwise what we have to do, we have to implement, we have to convert this thing into our concrete method. See, now things are how much relatable, right? Now you know the concept of interface, you know the concept of abstract class. Now you can understand that how basically all the things are basically we are executing all these steps. Okay. Earlier in the, if you don't know about the concept of interface, abstract class, then it becomes quite complex for us to understand these concepts. Now we are able to understand, okay, this is how, this is why we are getting an error. Is suppose if you are not basically executing that particular converting this abstract matter into your concrete. Now let's take this example, and using this how we are able to do it. Remember, so in this case we are defining a thread by runnable interface. So how can we do it? Remember, so I have created a class. So see, this runnable is an interface, so I cannot use extends keyword. I have to use implements keyword, and it is mandatory for me to basically override this particular method. So here I am basically writing my code. Now inside my class main method, inside my public static void method, one thread will get created. Okay, T1 thread, one thread created by our JVM by default. And after that, what we are doing, we are basically creating an object of my this class, right? So can we create an object? Yes, we can create an object of my runnable class, right? Because this is a what? This is a concrete class. This is not an abstract class. This is a concrete class. So yes, we can create an object of this class. So that is why we are creating an object of this class. Now let's forget about these two statements. Now let's assume if I am going to write th1, this is my reference variable, okay, dot start, right? if I am going to execute this statement, because you already know that using this method, our start method, we are able to perform what we are able to move our this particular thread from new state to runnable state, right? So this method is mandatory. Now, if I am going to execute this statement, then what will happen? Then remember, we will get an error. Now the question that comes into your mind is, sir, why we are getting an error? Remember, for this particular case, here we are basically creating an object of your runnable class. A runnable class is basically implementing which interface? Runnable interface. So do we have a start method here? No, we don't have start method here. So automatically here in this program, do we have start method inside my runnable class? No, we don't have. So we will get an error that start method not found. This basically not found, undefined. This error you will get. Now the question that comes into your mind is, then how can we perform this particular inheritance concept, basically multi-threading concept? Then for this particular case, whenever you are going to create a defining a thread by using runnable interface, then again what you have to do, you have to create an object of your which class? Your thread class. So this is a this thread class is already there. Why? By using import java.lang package, right? Now after that, what I will do, I will directly write it down t.start. Now again, remove this. Now, if I'm going to execute this program, even I can just to show you this particular thing so that you will have a better understanding. So what I'm doing over here, see, this is particularly my program, and now what I'm doing is, let's make it this one. Okay, comment. Right now in this program, I am again I will explain what I'm doing. I have created a interface over there, right? And this is basically having run method. You already know that we should have a run method over there, right? And in this class, inside my public static void main, I have created an object of runnable, and I am calling th1. See, this is th1 dot start, right? So let's execute this code. So once I will execute this code, see what error I am getting? Cannot find symbol. th1.start. Now you will say, sir, why we are getting this method? You see, start method. Where this start method? Do we have any start method? So are we able to find out any start method inside my runnable? No. Where is it inside our runnable? No. So how can we say that we have start method? So that is why what we are going to do, we are going to create a thread t your class, okay? Because this class contains what this start method. And after that, once we are going to basically execute this statement, now you will say that, sir, are we able to execute this statement? What will happen? Whether we will get an output or not. So remember, for this particular case, we will get the output only that is your main thread. So let's execute this code. Now we are getting only main thread. We are not getting the output that is your my runnable thread. Now again, the question that comes into your mind is, sir, we are creating an object of thread class and we are basically executing this particular thread. So why we are not getting an output? Remember, for this particular t.start, you are executing which run method of your thread class. We are not executing my runnable run class, right? So we are not executing this class. So how can we execute this particular run class? So for this particular scenario, we have to pass. So see, there are various constructors, okay, that are available in our thread class. I will show you those all these constructor, out of which this constructor, whenever you are calling this one, so in this particular scenario you have to pass this reference variable. Now if I am going to execute this case, so now you will find out that I am getting main thread and runnable thread. So whenever if I am who keeps on executing and executing, now see, I will get different output. So you can see that the order, we cannot predict the order. So who will predict the order? Our scheduler, right? So all these things we have learned so far. So this is all about, so it is mandatory that whenever we are basically creating our defining a thread by runnable interface, so always you have to create an object of thread class, and inside this constructor, okay, you have to pass a reference variable of your interface, this particular child class. Then only you will be able to execute this particular thread, right? Like this. Now the question that comes into your mind is, sir, now we have two approaches, right? How many approaches do we have? We have two approaches. First one is by extending thread class, and second one is by implementing runnable class. So till now, you will say, I am 100% sure that most of you will say that, sir, don't go for this runnable, this one. Don't go for this basically approach. Why should we go for this particular approach? Because again, we have to create a two object over there. So here in this case, how many objects we are creating? We are creating two objects, right? In order to perform the same operation. While in our earlier case, if we are not getting this particular error, then how many objects we are creating? Only one object. And using this object, we are able to perform our operation. Now, yes, any question? Okay.
Sir,
So, yes.
so in thread class, is there any other methods except run method?
Yeah, there are many other methods. So I'm going to show you the list of all other methods too, right? Even
Oh,
there are many other constructors too. I will show you just after this slide. You will get to know about other methods and other constructors, right? Okay. Now, now here in this particular case, now the question that comes into your mind is, sir, which approach we should prefer, okay, or we should recommend, right? So in our first case, so most of you, for our current scenario, see here how many objects we have to create? Two objects we have to create. Here we have to, how many objects we have to create? We have to create only one, right? So for this particular scenario, you will say that, okay, sir, it's better to go for this particular case. But remember, in most of the scenario, you will find that this is the recommended case. Now the question you will say that, sir, why are you saying that we should always go for this particular case, not our this particular case when we are only inheriting our child class? Because of the concept of your multiple inheritance. So does Java supports multiple inheritance? No, Java doesn't support your multiple inheritance. So for our first case, suppose let's assume my example thread wants to inherit one more class, that is, let's assume my test class, right? So can I inherit my test class, both these classes? No, I cannot inherit these two classes because with respect to our class, Java doesn't support our multiple inheritance. So we won't be able to do that. Okay. But here in this case, we are able to extend what? One class, as well as we can implement our runnable interface. So we are able to perform both the tasks over here. So that is why if somebody will ask you in any interview or in somewhere that which one you should prefer and which will be the recommended case, so always remember that your second case will be your recommended case, because through using this case you will be able to inherit one more extra class. One class you can inherit, okay, whatever the class you have if you want. So it depends upon your scenarios, but I will recommend you, well, if you want to inherit two classes, right? So for our first case, we are not able to do that. But in our second case, we are able to do that. So because you already know that use in interface, we have covered that we can extend as well as we can implement in a single line wherever we are declaring our class, right? So now you have an idea about that, okay, this should be our recommended case right now. Now the question which he has asked me, like, sir, is there any other method? Is there any other constructors that are there that is present in our thread class? That thread is our inbuilt class, remember? So till now, we have used how many threads so far? we have used only these two constructors so far, right? How many constructors we have used so far? We have used only these two constructors. But here are other constructors too, right? So other constructors, if you want to directly send the name of that particular thread, so whenever we are creating threads now, so we can also send the name of, we can pass the name of that particular thread too. We can also find out, pass the runnable target and string name too. So we are not going in the depth of all these things. Otherwise, our this multi-threading concept, because there are a lot of topics that are there under this your multi-threading concept. Okay, so you can call it as that multi-threading is entirely a different. You can say that a subject if we are talking about this your entire multi-threading concept, right? So we cannot cover in each and everything, but in this subject we are going to cover the maximum thing which will be very useful in our future. Okay, but if even if you are going to use all these things, like if you what if you require thread groups when you are having a lot of cluster of your what we call it as your threads, then you can directly create. So it is possible in Java. Okay, if you want to create your stack size, so you can create it, you can perform your runnable thread. So all these constructors are already there. Okay, but in most of the scenario you will see that we are going to use your this one and your this one, or if we might use your fourth one. Top four threads we might use. Okay, but first and second are the most common thread, right? Your constructors. So let's take an example of our third one, that is your string one. So here in this case, what we are doing, if you will see over there, that what I have done, I have created a child thread. So how I have created a child thread over there? See, I have created a child thread here, right? And this is the reference variable. And in my this thread class, what I am doing, I am calling basically this constructor, and here what I'm basically this, I'm passing the name of my this particular thread. Okay, that is my th1. So basically I'm using the third one, okay, for this particular case, right? So this is again how you are able to execute. So see here, I cannot comment on that whether I will get the same output every time. So every time I won't be able to get the same output. I might get different outputs, right? Like that. Now the second question which he has asked me, like, sir, is there any other methods that are there inside our your thread class? Remember, we are having a lot of methods. See, these all are multiple methods that are there inside our what your thread class, out of which we are going to discuss. So till now we have already discussed about your these two methods. We have already discussed about. Now after that I will tell you about, we are going to discuss about these two methods too. Later on we will discuss about these two methods, but after this, not in today's lecture. In our next lecture we are going to discuss about join method, or these methods might be possible, I might not able to use it, or it depends, like in some program you might get. Okay, so just go through these methods. These methods are not that much complex. If you'll go directly to the statement now, like if you want to set the name, so these two methods I will cover over here. So again we have one more method which I have not listed here, that is our get name method. I will tell you about the functionalities of all these methods. So I will cover most of the methods, okay, in our lecture. So the first two methods which I am going to use in this lecture is our get name and set name method, right? So what do you mean by get name and set name method? First of all, I'm just telling you about this. What do you mean by get name method? So using this method, which is known as your get name method, so I haven't mentioned over here, but we have similarly we have set name method. Here I have mentioned that changes the name of the method thread object. So what happened actually in our Java programming language, whenever we are creating threads now, so automatically our JVM will provide us some name to that particular thread. So remember that our thread naming will start from 0. So for this particular case, you can see that how many threads I have created. I have created this particular thread and this particular thread. How many threads I have created? Thread number 1 and thread number 2. Two threads I have created, right? like this. Even though we are also having this main thread. So if somebody will ask us, sir, how many threads are there in this particular program? So your answer will be like 3 threads. Okay. Not sorry. For this particular case, we will have only 2 threads over there. Now after that, if I want to find out that what will be the name of my thread, so what I will do, see, directly what you will do, you will directly write it down th1.getName. So most of these methods are what my instance method. So you already know that you can call instance method by using reference variable by creating an object. So this is what I am doing. So whenever I am writing that th1.getName, so I will get it head 0. So I am basically creating what my thread 0. He has assigned me the name thread 0. And for this one, he has assigned me a name that is what was. This is what my thread was. So whenever you are creating any object, so JVM will assign us some name to those particular thread, right? Like this. Now, what if we want to change the name of this particular thread? Suppose if we want to make our program simpler, okay, and we want that, okay, we should know that which thread we are calling, okay. Somehow we are also know we from our for our application applicability, we want that we should know the name of this particular thread. So for that, what we can do, we can set the name of our threads too. So if you want to set the name of our threads, so what you can do, you can directly call this method that is known as your set name method. So right now for your batch, let's assume I have created a thread. So what I will do, I will directly set the name BUCSE 2020 batch. Now what will happen if I'm going to print the name? So you can see directly that now JVM will address our this particular thread, our first thread as our BUCSE 2020 batch, right? So this is how basically you can set the name as well as get the name of your threads, right? This is very important. So if you are writing some program, you are getting some sort of complexity, okay, like in order to find out, okay, this thread is performing which operation, something like that. So it's better what we can do. Suppose I want to create a different thread from BUCSE 2021 batch, okay, so which is going to come now. So if suppose if I want to create a thread for 22, so in future if I want to perform some sort of operation, so I will directly call that particular thread. Okay, so now it becomes quite easier for me to perform. So if we have to apply some sort of, you can say that functionality of, if we want to give some sort of advantage to 2020 batch, so what I will do, I will directly find out the thread whose name is BUCSE 2020 batch, then you have to execute that particular thread like that. Okay. Now, after that, the question that comes into your mind is, sir, till now what we are doing is we are basically executing our code, and based on that we are getting different output, right? So we have, let's assume for this particular case, initially we have main method, and then after that we are getting 2 threads. First one is our th1 thread, let's assume, and second one is my main thread. And these 2 threads are basically executing randomly, not we can call it as randomly, but based on our schedule. But now, what if I want that this particular, I want to give the higher priority to my th1 thread. So let's assume you want to execute in your application, there are 100 threads, right? And now you want to give, or suppose you have only 5 threads and you want to give the highest priority to any one of the thread. So how can you give this particular priority? Can you give the priority that always it will execute your th1 thread? Okay, so yes, it is possible in your Java programming language by setting the thread priority, right? So it may be default priority set by the JVM. So right now we are not using, are we setting any priority for our this particular code? Are we setting? No, we are not setting any priority. So now if somebody will ask me, sir, can you tell me like what is the priority number? So remember in Java, the priority number is always listed between 1 to 10. Okay. The priority, if you want to set some sort of priority, 10 means highest priority, 1 means least priority, right? So this is the order. So right now, if you will say that, sir, whether JVM will provide us some sort of priority for this particular case, now, yes, Java will provide us default priority. And what is the default value of priority? Remember, 5 is the default value of our priority. So for this particular case, 5 is the default priority. So for our main case, again 5 is here. And for th1, because the class which is inheriting, okay, whatever the class, and if we are not setting any priority, by default, we generally got the priority as value of 5. Now you will say that, sir, we are getting a confliction among priority because both the threads are having the same priority. Then in that scenario, our scheduler will run that to whom we have to give the highest priority, right? Higher priority. So we can set it out like what the priority. So JVM is basically provide us the priority, but we can customize our priority too as a programmer. If you want to set the priority, so how can you set it? So in our Java programming language, like in our thread class, we have these three variables, right? First one is your min priority variable, second one is your norm priority, and third one is your maximum priority. So remember, minimum priority is what the value is 1, maximum priority value is 10, and normal priority is 5. So default priority, we always got this norm priority, right? So if you want to set the priority, so how can we set it? Okay, so let's take this particular example. So in this particular example, what we are doing, if you will see over there, for I have created two thread objects, okay, of my this particular test multi-priority one class, right? Now I want to set some sort of priority over here. So how can I set the priority? So you can see here that I have set it the priority of M1, my this one as what my minimum priority, and you know the minimum priority value will become what, 0. Similarly, I have set the priority for M2 as what my maximum priority, that is what, 10. So or for your main thread, if somebody will ask you what is the priority, that is 5. So this is how basically we can set a priority. If you want to write the value, you can also write it, okay? So there are two ways basically you can call this method. Either you can write thread.mean priority, but in most of the scenario, we never use this one. It's better to directly write down the value 1, 2, 3, between 0 to 10, okay? Right, sorry, between 1 to your 10. Now, in this case, if you are going to execute it, so we will get the output based on our priority. Now, if you will execute in your system, remember, if you will execute this system, and let's assume you will give the higher priority to your M2, but still you are getting the output, means you are getting it is executing your M1 method. Then you will say that, sir, why we are getting the output for our this particular object, okay, for this particular thread. Remember that this particular case, our priority, thread priority is dependent on our platform. Remember, it is dependent on our platform because somehow we are now using the services of our operating system. So if Windows operating system is not supporting us, the priority, so we are not able to do this particular operation. We are not able to perform this particular operation where we can set the priority. Now the question that comes into your mind, sir, how can we do it? So you will find out that there are many patches, okay, that are available related to that. So if you are able to basically download, install those patches, so then in that particular scenario, you are able to execute those particular scenarios. Okay, but in most of the operating system, you will not find these such kind of that. Right. So now this is all about our today's lecture. Now in our next class, we are going to discuss about that methods through which we can prevent a thread execution. Now, what if we want that we are having T1 thread, we are having T2 thread, we are having T3 thread, right? So right now, based on the priority, we know that if we are giving 10, 9, 8, So based on that, it will execute first T1 thread, then it will execute T2 thread, then it will execute T3 thread. But what if we want that we should prevent that first instead of T2, first we should execute T1 or T3, something like that. So there are three methods, okay, using which we can prevent our thread execution, and these methods are very important. Okay, so all these things we are going to learn in our next lecture. Yes, anyone? Is there anyone who is having any question, any doubt? Feel free
Sir,
to
in
ask.
the runnable method, we have only one run method, runnable
Yeah, yeah, yeah.
class.
Yeah, not class. That is a interface.
Yes, sir. Okay.
Yeah, yeah. We have only one method, okay, in your
Okay.
runnable. That is why, na, see what we are doing. You can even find it out by your own too. See, for this particular case, what I'm doing, I'm just implementing this particular. If let's assume if we have some other methods too, so you already know that in interface how many whatever the methods we are having only abstract method, right? So now it becomes mandatory for us to implement those methods, otherwise we will get an error. But right now we are not getting any error. So it means that in runnable interface we have only your this particular run method, right?
Okay. Okay, sir.
Okay. Basically, all the topics are linked now. Now you can find out a lot of linkage between all the topics, right? Like this. So now we are going to discuss our next topic, like related to our this preventive measure in our next lecture. Then most probably, like most of you are having a lot of doubt related to this swing application. So you can tell me like whether should I perform some sort of hands-on, right? Related to your swing application, so that now after that particular extra lecture, you will be able to create your own application, swing application. So if you want, you can directly tell me about that. Each BRs, you can contact your BR, and BR can tell me about, okay, yes, we want some sort of time, this particular extra class related to that, so that I can conduct an extra class, right? Like this. So this is all about our today's lecture. So let's, yeah, sorry. So we will discuss our upcoming means other